I'm Anil Kumar sharing with you application questions on sine law. Thanks to my subscriber Ashwita for sharing these questions, and I hope their solutions will help you all. Now, here is the very first one. I have given the title chord length. You can always pause the video, copy this question. I will solve this question without using sine law, but this can be solved using sine law also. Right? Then I'll take up another question which is based on distance, speed, and time. Again, where sine law will be applied to find the solution. And then we'll take up another application question where we'll find length of the chord. So these are the three questions which I am going to do in this particular video, and I hope their solutions help you to understand the application of sine law, and also that at times we may not really apply it, right? Now let's look into the very first question. It is from a position 110 km northwest of a Coast Guard station, an oil tanker makes radio contact with the coastal guard. The tanker is traveling due south at 25 km per hour. The radar unit at the closest guard station has a range of 90 kilometers. For what length of time can the Coast Guard expect the tanker to be visible on the radar screen to the nearest tenth of an hour? Now, let me sketch the situation. Let's say that is our north-south line. This is east-west. So what we have here is from position 110 kilometers northwest. So this is north, northwest. So this is north, this is west. 110 kilometers, that means 45 degrees with this, right? Somewhere here, let's say somewhere here. Okay, now we'll make this. Where this angle is given to us as 45 degrees. And this distance is given to us as 110 kilometers. 110. An oil tanker makes radio contact and the tanker is traveling due south at 25 kilometers per hour. So it's like moving like this, kind of like this. And the speed is 25 kilometers per hour. Now the radar unit at the Coast Guard station has range of 90 kilometers. Now what does that mean? It means that it can only reach up to this point. So it is, radar unit is right there. So it could be, so if I take this as 90 here and make a circle, kind of like this, right? So as you can see, during this path, it is this interval when the radar screen will see the oil tanker, okay? Now, in this particular situation, the distance from the radar position to this point will be how much? In these two extremes. Since the range is 90, it is going to be 90, right? 90 kilometers. Now we want to find the time when the radar is visible on the screen. That is to find first this distance, or you can say the chord length AB, and since we know the speed, we can divide this length by the speed to get time. Correct? So that is a strategy. So it becomes a case of ambiguous triangle. We have two triangles and of course chord length, so we could apply sine law, right? Now we'll actually use another method here, and that is from the initial position. Let's say this is our initial point P where the ship or the tanker makes a call. It is 110 distance away, making an angle of 45 degrees, correct? So that means this angle is also 45 degrees. So let's find the point here. Let's call it Q. Now, what is the distance from the origin to Q? Let's figure out this point. From origin to Q, we know this angle is 45 degrees, right? So, cos of 45 degrees, to find OQ, we know OQ over OP is equals to cos of 45 degrees, correct? So from here, we can find what OQ is. So this gives you OQ, the base of this right triangle, is equal to OP. OP is 110 times cos of 45 degrees, correct? So we can figure this out. So it is 110 cos of 45 degrees is equals to 55 square root 2. Correct. Now once you know what OQ is, we also know that OA is 90, right? This is 90, and we know the base. Since we know the base, and that is a right triangle, we can find what AQ is, correct? So AQ should be equal to, that is a right triangle. This is a right triangle, and therefore we can write AQ is square root of 90 square minus this square. Let me write it in decimals. We already have this. Let me write this in decimals. 77.781 square root, right? So this in decimal is 77.781. Okay. So we can find AQ, which is square root of 90 square minus 77.781 square. It is equals to 45.278. So we know what AQ is. Now we also know that AQ should be equal to QB, right? QB. From the symmetry, correct? From the symmetry. And therefore, we know that AB is the duration when the tanker is visible, is 2 times 45.278, which is equal to, so we'll multiply this by 2. So we get 90.556, correct? So we haven't much used sine law here, right? Now, you know the distance speed relationship with time. Distance is speed into time, right? So what is time equals to? So time will be distance over speed. Distance in our case is AB, which is 90.556, and the speed is 25 kilometers per hour. So we'll divide it by 25. So we'll divide this by 25. We get 3.622. We want to write answer to nearest tenth of an hour. So that gives us 3.6 hours. Does it make sense to you? So we haven't really used our concepts about sine law, but we converted this to a right triangle. So as you can see here, triangle AOQ, right, so AQO is right triangle, is it okay? And therefore we use Pythagorean theorem here. And then we solved it like a right triangle to find AQ, and from symmetry we found the total length, divided it by the speed to get the time. So that is how we could solve this question very easily. Perfect. So try to find easy ways of such solutions. Now let's take the next example, which is A plane leaves an aircraft and flies due north at 500 kilometers per hour. The aircraft carrier proceeds 30 degrees west of south at 35 kilometers per hour. If the plane has enough fuel for 4 hours of flying, what is the maximum distance north it can fly so that the fuel remaining will allow a safe return to the aircraft carrier? You can pause the video, answer the question, and then look into my suggestions. The question here is, a plane leaves an aircraft carrier and flies due north at 500 kilometers per hour. The aircraft carrier proceeds 30 degrees west of south at 35 kilometers per hour. If the plane has enough fuel for 4 hours of flying, what is the maximum distance north it can fly so that the fuel remaining will allow a safe return to the aircraft? So first let's sketch the scenario and then we'll try to solve it. So the plane is flying north from the carrier, which is here. So let's say that is the direction north for us, right? So this is north. And the aircraft carrier moves 30 degrees west of south. So this is south. So 30 degrees west of south means in this direction, correct? Where the angle given to us, this angle, is 30 degrees, right? So of course this is 90 degrees, so that becomes 60 degrees, correct? So we can say the angle here is 60 degrees, right? And this angle is 90 degrees, okay. Now the plane has to return to the aircraft carrier. That means wherever it flies to, it'll try to come back. So let's say it comes back from this point back to the ship. So it's kind of like this. Do you see that? Kind of like this. So let's call that point extreme point up to which the plane can fly as A, return to position B, and we'll call this as O. So as we are given, total time is T for us, right? So let's say plane flying north. If the plane is flying north for, let's say, time T, speed is 500, so it'd be 500 T is going to be the distance, right? We'll use this distance, we know the triangle here. Let me just make a triangle here to relate distance, speed, and time. So we know distance is speed into time, correct? So the speed during this period is 500 kilometers per hour and time is T hours, right? So it is OA. We'll say this is OA for us. Is it okay? OA. Now the return for the plane, which is AB, is also with the same speed of 500 kilometers per hour. So we'll write 500 for the speed, but the time taken will be 4 hours minus T, since it flew for T hours north, and total time is 4 hours, right? Since total time is 4 hours, otherwise it will not have enough fuel to return, correct? What is OB equals to? Let's calculate that also. OB, aircraft carrier is traveling with 35 kilometers per hour, right? So it will 35 times 4 hours, which is 4. So let's multiply this. So we have 35 times 4, which is equals to 140, right? So all these distances are in kilometers. So we know OB is 140. So now we have a triangle where we know 3 sides and also the angle. We also know the angle AOB. This angle is 90 plus 60, which is 150 degrees, right? So if you know three sides and an included angle, you can always apply cosine law, correct? So we'll apply cosine law to solve this question. Perfect. So the relation is that this longer side, which is opposite to the given side angle, AB square, which in our case is 500. So let me write down here. This side here is 500 times 4 minus t, right? So that side square, let's write down 500 times 4 minus t whole square should be equal to sum of these two sides, which is 500t whole square plus this one is 140 square minus twice product of these two, which is 500t times 140 times cosine of angle, which is 150 degrees. Does make sense to you, right? So what we get here is an equation in terms of t, right? So we can always solve this equation. So let's open this bracket on the left. 5 times 4 is 20, so we get 220 minus 500t whole square equals to, now we can open all these terms. So 25, 4 zeros, 1, 2, 3, 4, t square plus 140 square, let's do 140 square, 19600 minus, let's multiply all this, 2 times 500 times 140 times cos of 150. So it gives you negative something, so that makes this positive, right? So let's make it positive. It is 121,243. 121,243 point, let me write this 56. Okay, so we got that. On the left side, we have a minus b whole square. We can expand this. A square minus 2ab plus b square. Okay, and well, there was t also here, so let me write t also here. Perfect. So square of 2000 will be 4. 2 times 2 is 4, and 6 zeros. That means 4 million, right? 1, 2, 3, 4, 5, 6. Minus twice these terms. Let's do it. Which is 2 times 2000 times 500 is 2 million. 2 million t, right? Plus square of this, which is 25, 4 zeros, t square, right? And on the right side, which is 25, 4 zeros, t square plus 196, 2 zeros plus 121, 24356. Okay. Let's do this calculation once again. Let me just check this. 2 times 500. Let's do 2 times 500 times 140. And then we'll multiply by cos of 150. So it is 121,243.56, correct. So 121,243.56, correct. So if you see, these two terms cancel out. We are left with terms with t's and the constants. So let's bring the constants together. So we have 4 million minus 19600 equals to 2 million 336 plus 121,243.56 t. Well, this is with t. Okay. So, this is also with t. Right, this is with t. So these are the terms with time. So let's do that difference. 4 3 zeros, 3 zeros, take away 19600 equals to 3980400 equals to, let's add those two, 2 million. 3 zeros, 1 2 3 plus 121243.56 equals to 2121243.56 t. Right? So from here we can find what t is. So t is equal to this divided by that. So 3980400 divided by 2121243.56 equals to, let's do that. So we have 3980400 divided by 2121243.56 equals to 1.876. 1.876. Okay. So that is the time t in hours, correct? So we want to find so that the fuel remaining. So what is the maximum distance? We want to find maximum distance north it can fly. So that is the time t. So the distance is 500 times t, correct? So we can now write that the distance will be equals to that into 500. So this is the distance which is our answer. Distance it is flying north, right? This distance. So that should be 500 times 1.876. So we already have that number, times 500 gives us 398.2. Let's round it to the whole numbers. So 398 kilometers. Does make sense to you? So that is the distance, maximum distance the plane can fly safely north, rounded to whole numbers. Is it okay? So it is an application of cosine law. It requires a lot of calculations, although the concept is simple, right? I hope that helps you to understand how to solve such questions. The question here is, the distance between the centers of the circle A and B is 60 meters. Each circle has a radius of 40 meters. Point C lies on the circle with center B. Angle BAC is 41 degrees. What are the possible lengths of AC to the nearest meter? So let me complete this diagram. We have these two circles with the centers at A and B. Right, so this is A for us, center at B, and the point is C on the circle B, right? We are also given that the distance between A and B is 60 meters. So this is 60 meters for us, A to B distance. The angle A is 41 degrees. Let me write 41 degrees here. So that's the angle A here, right? What are the possible lengths of A to C? A to C. This is what we need to find to the nearest meter. Now C is a point on the circle. So from the diagram also you can say C could be at these two positions. Let me just sketch these positions. So let's say C is here. So we can form a big triangle. And if there is a possibility, that could be the second, right? But C could be tangent also, right? So there may or may not be a possibility. So first let's figure out if we have two triangles or one triangle. BC is 40 since the radius is 40 for both the triangles, correct? So what we should do first is see if the perpendicular distance is less than 40 or not, right? So this perpendicular distance will be 60 sine of 41, correct? So let's compare BC. What we know here is that BC is less than AB, right? And it's an acute angle. So we'll compare for B sine theta, which is, let's calculate what is 60 sine of 41 degrees, right? Let's compare 40 with this. So we have 60 sine of 41 degrees. That gives us 39.36. Correct? Now, since 39.36, that perpendicular distance is less than 40, right? That gives us ambiguous case, right? Two triangles. Perfect. So we are expecting C dash also. So remember that, right? So we have two triangles. So what are the possible lengths? That there are two possible lengths of AC. One could be written as AC, the other one is as AC dash, right? So I hope this part is very clear. Now let's figure out what is the angle C first. We'll find this angle using the big triangle ABC. So let's analyze the big triangle ABC. Now in this triangle, we can apply sine law. We know the ratio of A and A. So to find angle, we say sine of angle C over opposite side is 60 is equal to sine of 41 over 40. Correct? So that gives you angle C as equal to sine inverse of 60 over 40 sine of 41 degrees. Correct? Let's find this angle. So we have sine inverse. Let's put one more bracket. We'll do 60 divided by 40, right? And then we'll multiply this by sine of 41, bracket close, equals to 79.76. So that's the angle, 79.76, right? You could round to 80 degrees. So let's keep 2 points, and then we'll go further. Now if this is the angle here, so that angle is also for this side. So both are, this is also 79.76. So this angle here, the smaller one will be what? The smaller one will be 79, because this is an exterior angle, 79.76, take away 41 degrees, right? So that is going to be, let's take away 41, is going to be 38.76. Okay. So we just worked that out also. Anyway, so that's a smaller angle. But first let's find the bigger angle. I mean this angle, which is angle B, right? Now, so angle B is equal to, so when I say angle B, we are still working triangle ABC. That should be 180 degrees minus 41 minus 79.76. So it is 180 minus 41 minus 79.76. So in decimals, 59.24 degrees. Correct? Now, once you know this angle, you can find AC. We need to find the length AC, right? So we can again apply sine law. So we say AC over sine of this angle, which is 59.24, should be equal to 40 over sine of 41, and that gives you AC as equal to 40 times sine of 59.24 over sine of 41 degrees, correct? These are all in degrees. So let's calculate this. So we have 40 times sine of 59.24, and we'll divide this answer by sine of 41. And that gives me 52.39. So we have to round it to nearest meter, so I could round this to 52 meters, correct? So AC, one possible position is 52 meters. Now we'll look into the smaller triangle, which is kind of like this. Correct? Let me write. So here this angle is 41 degrees, and this small angle, which we just worked out, is 38.76. The sides given to us are 60, and this is the radius of the circle from B to C dash, that is the point A, 40, correct? So this is 40 for us. So in this triangle, since the small angle now is 38.76, same formula, so we say AC dash over sine of 38.76 equals to 40 over sine of 41 degrees. So we can say AC dash is equal to 40 times sine of 38.76 over sine of 41 degrees, correct? So let's calculate this. It is 40 times sine of 38.76 divided by sine of 41, which is equals to 38.17, or approximately 38, right? The units are in meters. So we get our answer that these dimensions could be 52 meters or 38 meters, correct? So that is how we could actually solve this question. I hope you highly appreciate what we have done here. So we have used the best methods to solve. Feel free to write your comments and share your views. If you like and subscribe my videos, that'll be good. Thank you and all the best.